Hi Abby, how are you?
I'm doing well, thank you.
Now, tell me the name and a little bit about your project.
So the name of my project is Sir Arthur Eddington's total solar eclipse observations, and in the goal of this experiment was to prove Einstein's theory of relativity, that his observations and some of his arguments with the Newtonian theories of light were not just theory, that he's actually correct in his theoretical studies of light and how gravity and time and space are relative to each other. For example, how light travels through space to Earth.
Now, with your experiment, what was your main goal? What were you trying to do?
The main goal of our experiment, just like I said, was to prove that Einstein's theories of relativity were not just a theory. So we wanted to prove that gravity bends light as it heads to Earth, say from the stars, and we wanted to prove that light it travels and will bend around an object even through a vacuum like space. We wanted to prove that basically the science of relativity, that's the space-time continuum and the things that Einstein had theorized about were correct, in fact. So we used that Hyades star cluster and observed the power and the heat and the energy of light coming from that star cluster previous to our experiment, so that we kind of had a baseline for our data. And then when it came time for the total solar eclipse, we observed how the light and the power, the energy of the light changed during the total solar eclipse as the light from the stars traveled around the sun to get to Earth during the darkness of the eclipse. And we were able to see those stars because of the darkness of the eclipse.
Okay. Now, where did the experiment occur?
So in 1917, one of our team leaders, he's actually an astronomer royal of Britain, named Sir Frank Watson Dyson. We started in 1917 in Britain. Just he wrote the experiment, and we devised a plan how we were going to conduct this experiment. And the lead on our experiment was actually Sir Arthur Eddington. He kind of took charge after Sir Dyson wrote the experiment, and Sir Eddington ran with it, built our team, gave us instructions, told us how we were going to conduct this experiment and what we were going to do and whatnot. And then fast forward to 1919, we actually conducted this experiment on 2 separate places, just in case that it was cloudy or the weather was bad the day of the solar eclipse. We knew we had one shot to make sure we got this right. So Sir Eddington and I and one other scientist were on an island called Principe off the west coast of Africa. And Sir Dyson and 2 other scientists were actually in Sobral, Brazil, and thankfully both of those days the weather was perfect. So we have perfect data from 2 different places that both got to see. We got to see 6 total minutes of an eclipse, and in Sobral they saw about 6 minutes as well. So we had more than enough data to complete our observations and prove Einstein's theory of relativity.
Okay. What was happening in the world at the time?
So around the world, World War I actually has just ended within the last year. America has come into a period of economic upturn, and their economy is booming, and technology is booming in the United States. We later learned to called that the Roaring Twenties. Herbert Hoover has sent war aid. The Treaty of Versailles has just been drafted, and the German colonies have been, dissolved, and France and Britain, we have received some of that land back. Some of the land that Germany had occupied has gone back to the Africans in Africa, since it was connected to the continent. Actually, in January of this year, the German Farmers Party just became the German Nationalist Party, or the Nazi Party, as they were soon to be called the Nazi Party for short. That's pretty much it that was going around the world. We later found out after our experiment that actually in Turkey, the Turkish War for Independence broke out on the same day of our experiment. So that was something interesting to find out what was going while we were looking at the eclipse. That was what was going on somewhere else in the world. But yeah, that was pretty much what was going on during the time of our experiment.
Okay. So who else was involved in this project?
Like I said, our team lead was Sir Arthur Eddington, and he worked with Sir Dyson to make this happen. We had a few assistants for each of the men. And Sir Eddington actually told Albert Einstein, we're hoping to prove your theory of relativity. This is what we're doing. Brought Einstein not onto the project. He wasn't involved in our experiment. He was aware, and so as soon as we were able to publish our results, he was made aware that he was in fact correct, that his theories were all correct, and he was right. And of course, I'm sure that was nice to hear. But yeah, that was pretty much all the scientists, physicists that we worked with for this experiment.
Okay. What was your specific role in the project?
So my specific role at the start of the project in 1917 with Sir Dyson was to kind of just learn about the theory of relativity and the procedure of this experiment. Well, how are we going to make these observations? What were we looking for? What calculations did we need to do? And Sir Eddington kind of explained to us what he expected of us, what we needed to do, what observations we needed to make. And I helped Sir Eddington observe the Hyades star cluster in January, February of 1919, previous to us conducting the experiment and making our observations. And I went behind him and helped with the calculations, made sure that we took all the observations we needed. That we needed to conduct this experiment and make sure we have a baseline of our data so we could compare and contrast. And then once the day of the experiment came, I was on Principe with Sir Eddington, and I was able just to go behind him and make sure we had 6 minutes to get this right. So that whole 6 minutes I was making observations, recording data, so that we could go back and conduct some calculations and we wanted to prove that the theory of relativity was true, and that was absolutely interesting to see. We were the first group of scientists to do this. We were the first to actually put this into a working experiment and not just theorize if it was correct or not.
Okay. Now, what impact did you and your team's project have on the physics community?
So the impact we had on the physics community was that this was the first experiment of its kind. No one had tried to no one had tried to conduct an experiment like this before, to prove or even disprove Einstein's theory of relativity. And the day after we published our results after the experiment, Einstein's name was headlines on all the newspapers worldwide, not just in the physics community, worldwide. Einstein was a world-renowned scientist, and then by our results, his credibility shot up. He was just, he was a theoretical physicist, but he was the best so far. And he later in 1921 went on to win the Nobel Prize in theoretical physics. He was awarded that prize in 1922, and this helped, even to this day, theoretical physicists look at the theory of relativity as absolute truth. It's no longer just a theory. So that's the impact our results and our experiment had on the physics community.
Okay. Now, what was the most challenging part of your project?
Oh my goodness. I'd have to say, I think just the sheer preparation was challenging. It took 2 years and we had 6 minutes. So we worked so hard for 2 years. Sir Eddington, Sir Dyson had worked so hard to make sure that this experiment was spot on and that we were ready to go to make these observations and that we maximized our time in that 6 minute window. And that was a lot of hard work. It was kind of grueling some points. They wanted to make sure we had it right, and they like to be accurate, and they're really nice to work with. But I'd say that 6 minute window was stressful. Just knowing that start to finish, you couldn't mess up. You had one chance. You can't go back and redo the trial. You can't conduct the experiment tomorrow. We had no idea when the next total solar eclipse would be. So it was vital that, during that 6 minutes we got enough information on that Hyades star cluster to make sure that we had enough to compare from our data in January and February. So I would say that would be our most challenging part of conducting the experiment.
But it sure paid off.
Yeah, absolutely, yeah.
All right, well, thank you for your time.
Thank you so much.